Gonna wait a couple minutes to see some more people show up, and then I'll get started. And hello to anyone who is gonna join a little later. We'll wait till about 5:03, and then I'll get started. I hope everyone's doing well and getting through this cold front that's been coming in. I had to drive through a lot of the snow squalls that came through on Friday yesterday. I literally couldn't see it all. I had a small blizzard. It was a very kind of dangerous situation. So I would not recommend driving through a blizzard. And it just so happened I was on the highway when that happened. But yeah, so I guess we'll get started now. So I am John Fritsch. I am running Whether or Not here. I'm glad you decided to join or are watching later. I grew up here in Virginia, specifically in Northern Virginia, in the Falls Church City area. And I went to Virginia Tech later on and graduated with a bachelor's of science and meteorology. And I'm just here to share some information about this winter storm coming up. So if you have any questions about what I'm talking about throughout the stream, you're welcome to ask me afterwards, or you can email me, which I'll have my email at the end of the store, or the stream, end of the stream. And this is my first stream, so we'll see how this goes. So let's get started talking about Winter Storm Blair. So first, I wanted to bring up, which is what's on the screen right now, the European model, which I believe is showing the best run or track for the storm. The reason being is it shows about the average track of all the models right now. Some of them have the storm going, some of the models have the storm going a little more north, and some have it going a little more south. But this one is about a good average, and the European model is usually pretty accurate. I also, this is a personal thing, but my history with the GFS in the American model is that it can tend to be a little warm. So I sometimes tend to look at the European model a little more than the GFS, but I still check out the GFS. So here's that first model run, and as you can see, it's a decent sized storm. It's going to affect a lot more southern parts of Virginia than a typical snow. And it's going to definitely be a storm to mess up plans on Monday, so be prepared for that. So let's get into the timing of this storm. To do that, I'm going to actually go into the National Weather Service alert for the winter storm warning. So the winter storm warning they currently put out, they just updated it recently, is showing that areas around Northern Virginia, where I'm at, is outside DC. This is for areas, or in like for areas in Fairfax and Arlington, Alexandria, Prince William, Loudoun County, Fauquier County, lots of areas around here. They're telling us about how the total sleeting accumulations could be between 5 and 9 inches, which is increased from their last warning, which just said 5 plus. Now they say between 5 and 9. And now with the squall lines going up to 10 to 12, where before it only said 10. So it looks like this, they're expecting a little bit more than they thought beforehand. So definitely be prepared. And the timing is from 10 p.m. Sunday to 1 a.m. Tuesday. That's pretty good time frame for the storm. So moving on to when will be the most heaviest time period for the snow. I believe looking at the models, it should be in the morning hours or later morning hours. So if you're still planning to go to work that day, be really careful. And as we can see right now on our map, we got all our storm warnings. Just reloading the page. Yep, winter storm warning now. And here's the current satellite image of the storm. It's kind of hard to see now because the sun's setting, but you can see the general long pattern of the clouds making their way slowly over here. So getting more into the models and why I've been thinking about these things that I've been telling you is we're first going to talk about the positioning of the low pressure systems, which kind of track where the storm's going to be going. So first, I tend to look at 3 models, main models. I do look at all of them, but there's 3 I mainly look at, which are the GFS, which is the American model, the Euro, which is the European model, or actually on here is the ECMWF. And then I also look at the GDPS, which is the Canadian model. That one's not as commonly used, but I like to use that one personally. When I was looking at their latest runs and tracking where the low was going, there's actually a little bit of a disagreement between the American model and the European model. The American model, which I have on this next tab, is showing the low tracking towards the West Virginia and then dipping down to North Carolina going off the coast. Where then if you go to the European model, it does about the same thing, but it starts off a little more south and even drops farther south than North Carolina. And they may seem pretty similar, but the difference between where the low can be can really impact temperatures and whether there's going to be a wintry mix or not. So if we go back to the GFS model, when it originally drops over into Virginia, it's actually closer to us, the Northern Virginia area, and that could cause temperatures to be a little higher, which could cause more mixing in some of the southern areas in Northern Virginia. So that might decrease snow totals, where for the European model, it's actually in a perfect location. It's a little farther south that there wouldn't be a risk for more of a wintry mix to decrease snow amounts. And then I also checked out the Canadian model for the low pressure tracking of this storm. And it's actually a nice smooth track, but it's a little even farther south. And because of that, there's less moisture coming up north. So their snow amounts are a little lower for the northern parts of Virginia. So the Euro is like a little bit of an average between the American and the Canadian model, which I think is why I'm also trusting it tonight, because it's a little bit of a average. Okay. So now we're going to check out where the moisture is coming from, which, here we go. So the moisture we need for the storm is coming up from the Gulf of Mexico. You can see that line of storms right there. And you can see the low pressure, which rotates counterclockwise, helping to deepen the cold front that's coming down here, or the trough. And that'll help bring in that cold air after the storm. And then there's also a low pressure up above it, which is also turning counterclockwise and helping push the cold air down a little bit. That may not be a big factor, but I think that's also helping keeping the cold air up in the New England area. And you can see the storm's gonna go up kind of the part of the coast, and then it's gonna go off into the sea. Yeah, that's just kind of just stepping back to see, hey, where's the moisture coming from? So getting the moisture from the Gulf of Mexico, that's a really good resource for winter storms. And if this moisture was just coming across the United States or from the Gulf, not the Gulf, the Great Lakes, I wouldn't be quite as concerned about a storm, because usually there's not enough moisture to do anything significant. But as you can see, we have a winter storm warning, so this is a bigger issue. So I guess getting into what the trends are and how things look for this storm, by the way, I'm going to put a snow map up at the end of this. So I'm kind of explaining how I'm getting to my snow map. So now if we look at how the models are doing compared to what's actually happening right now, what I've been seeing is the models are actually predicting the temperatures to be cooler than what's actually happening here. And I'll show you right here. So this is a weather station reading out of the Reagan Airport in DC. It said about at 1 o'clock it was 33 degrees. And about that same time, the weather models had it was supposed to be 31 degrees. And it just shows that it's a little warmer by 2 degrees than what the models are thinking. And 2 degrees can make a big difference. If you have snow at 32 and it's 34, it's going to be rain. So like 2 degrees can make a big difference, especially for wintry mix and snow amounts. And then let's see. Ooh, thanks for the snowflakes. Let's see. It seems that since that they're predicting, the model, what do you call it? Since it seems like it's being warmer than what the models are saying, that might cause a little bit more mixing, but it also might bring more moisture for us for the storm, which could increase snow totals if it just stays cold enough. And reason being is, this is what I want to show you now. Let's see. So this is a European model right here. Every time I flip between these, it's just a different run from a different part of the day. So every 6 hours, it produces a new model to see, or to try to track how changes are going throughout time. So like this is the morning run, and then it got new data and did another run for the same time. So this is kind of updating what's happening in the atmosphere, and then seeing how that changes for the future we're forecasting. So if we watch here, this is the models from last night. If you watch the top of the storm up here, if you see where my mouse is, you'll see as I progress forward, the snow is going to move north, which, as you can see, there's a big pink blob, which is really heavy snow. And as I'm moving the model runs to be more recent, you can see that that blob and the kind of the snow at the very top of the storm move north. I mean, sorry, it just bug jumped to a really old one for a second. I'll do it one more time. It's moving forward, and you can see it moving up. Beginning, there's less stuff up here, and there's more now. So there's like a slight trend north, and you can see that pink blob move up a little bit. So I think there's a chance that with these warmer temperatures and that we're seeing now, that's kind of why the European model and other models may be trending a little farther north for the storm. Yeah. But I'm not really concerned, because when I look at the freezing line, which is right here, it's the 540 line. You see this blue line right before the red ones. It's isotherm. That's the line of freezing temperatures. And when you look at the weather sounding, you click like about right up here in Northern Virginia, you can see up here on the left side, the red line is the temperature, and this dash blue line is the freezing section for the atmosphere, or freezing temperature line. If you follow what the red line is, which is the current temperatures for that time throughout the atmosphere, you can see that the temperature is stable of freezing all the way through, which means that snow can make it to the ground. You can see there is a little nose almost trying to poke its way out from freezing, but luckily it stays in there. If that nose, like if it is a little warm, like I'm saying, that I'm seeing, that could decrease snow amounts, because maybe that nose is going to poke a little bit out. So when our snow crystals, or when our snow starts to fall through the atmosphere, it'll melt a little bit and then refreeze, and that's when we get like sleet and ice. So yeah, so that was the GFS sounding, but it's kind of similar to the European model one, where it's below freezing even more. Like the GFS one I just showed you, I already told you, it kind of trends. This model typically trends a little warmer than it's supposed to be, so that's not surprising that it's a little closer to above freezing temperatures in the atmosphere, where this one is not, where the European is not. Also, the European is showing something which I'll talk about later right here. It's a big dry spot in the atmosphere. So this green line is the relative humidity, and when it matches up with the temperature line, you get saturation, and that's when like condensation and clouds can form and it can rain. But if it's too dry, there's this big, they separate basically, and there's this big gap. And when there's this big gap, you can't have a lot of precipitation. And that actually will play into my snow map a little bit at the end. The model that I've been following so far, it's one of the really short-term American models called the RAP. I think that one's been predicting things pretty well. It's a little too far out to use it for at least for 2 months right now, but just atmospherically, it was following the temperatures and the pressures really well. So I'm going to be following that one in the future. So let's see. Now getting to the snow map. So with all that I've said, put that all together. This is kind of what I'm thinking for snow amounts around the Northern Virginia area. So here's the snow map, or snow accumulation for the winter storm. So for the upper areas up here, you get 7 to 8 inches for Loudoun County and west and east kind of there. You get 6 to 7. And then there's a section a little farther south, kind of south of Springfield, south of Warren County, that is 5 to 6 inches. And I'll explain why it's 5 to 6. You're probably like, wait, how is there more above and below but not right there? I'll explain that in a second. And then 7 to 8 actually a little farther down. So if you look at this next slide, or this next model picture that I have, it's of the GFS. And as you see, there's a little spot right here in the middle of Virginia, or kind of the northern middle, where there's just less snow. And that's connected to why I have less snow here, 5 to 6 inches. It's because, as you can see, there's the mountains of West Virginia right before that hole, kind of like snow hole a little bit. And that, when storms go over mountains, they help condensation and precipitation occur when the moisture goes up a mountain. So it's basically losing a bunch of its moisture before it can make it all the way to us. So that's kind of what the mountain's doing right here. You see that big red blob because the mountain's helping precipitation to occur and trying to drain the moisture in the atmosphere before it gets over. So there could be this dry section in the atmosphere, which is what was kind of showing up on the European model right here. Yeah, the big dry section. So we got to be watching out for that, which is why I put less snow in that little southern area here. And then, so yeah, back to this snow map. This is kind of what I think conservatively could be the amounts of snow. I think there could be more just because of the trending north of the storm that I've seen. And because of that, I actually made a second snow map, which is like the best case scenario. If the trend actually continues and the storm moves a little farther north, this is what I think would happen if the storm moves a little farther north. So we're moving now, that northern area, it actually only increases a little bit. It's now 8 to 9. And then for my area, like Falls Church, Fairfax area, Loudoun County, it gets moved more up to 8 to 10. And then that southern area, which I still think there could be more dry air in there. I'm still putting 6 to 8 inches. Still a pretty good amount, but I think it's decreased because of that mountain and the way the storm's going to be going over the mountains. And then the bottom area, like south of Fredericksburg, kind of, or the southern part of Virginia, we're starting to get to more 10 to 12 inches or almost a foot of snow. And that's because on the European model, let me see if I can pull that up real quick. If I go to snow amounts, pull that up here, not this one. Oh wait, no. Here we go. If I pull this up, every model run, there's this little tiny pink blob, which is very heavy snow, and it's kind of brought up in the winter storm warning. But I mean, this is this model's for farther south than our area, but it's talking about the chances of heavy banding setting up, and that heavy banding, that it's probably what's showing up here in the pink, is the reason why I'm putting more snow in that southern area. And now I think, as I showed you, that the models have been shifting a little north. So that pink area, here we go, this is what I want to find. That pink area is moving around. You can see it moving around. And I wouldn't be surprised where, like, in this run of the European model, it's a little farther north. So if that's the case, then snow totals will definitely increase. So I'm also kind of confident that this could be a possibility. I think there's more of a possibility of the storm to over exceed our expectations than to under exceed. But it really depends on how much of that moisture is taken out when the storm gets over the Appalachian Mountains. The last thing I want to look at real quick before I wrap things up, and thanks for joining, is the total amount of ice. So there might be a little bit of mixing, and I'm bringing up the GFS model for this reason, because it had the warmest outcome for our area. It has areas just south of Springfield with some ice, actually a decent amount of ice. You're almost getting, I guess it's like a tenth to almost a quarter inch. And there's other areas in Virginia definitely going to be affected by ice. So that's going to be a big issue. But for our area, mostly we should be good. But again, we'll have to see how the trending of it being a little warmer is going to impact that, because maybe the ice will be a little farther north than what it's showing right here, and we'll have a little less snow. But I think there's a good chance of a good amount of snow, and ice probably will not be an issue. Also, on this note of ice here, the GFS model, if you just look at what it's showing for currently, actually let's see what the newest one is. It just came out. As you can see, there's a slight section right here where you can kind of see that dry air coming in, this dry pocket of air. There's probably decreased snow amounts. But then you also see about where we are, there's this little wintering mix. That's due to that low pressure system being a little too far north for us. We also don't have the classic high pressure system sitting off in this top, oh, sorry, just jumped ahead, in this top part of New England here. When that high pressure system's up there, it's like what people call like a blocking kind of high. It rotates clockwise, and it helps keep cold air coming down. We get cold air damming, but there's not quite much of that in this storm. The cold front and the low, where its position, is the really most important factors for this storm. So I feel like it's going to be a little easier for warmer air to move up into our area. But you've already heard my opinion on the snow amounts. So I think we're still going to be having a great snowstorm if you're excited for that or not. And I think school closures, or even, I guess you could say work closures, are probably pretty certain at this point. But if you still have work and you need to drive somewhere, I'd just say be careful. Drive slow, because it's really unsafe driving on these roads when there's this much snow, especially in the morning time when that big band of snow seems to be coming through. Just be safe. And if you have any questions, let me know. You can put those in the chat now if you have any questions. And I'll hang around a little bit. And just thanks for tuning in. Let's see how much the GFS is giving us right now. Oh, actually, that's a little more than it usually has been giving us. So it's about 6 inches, 7 inches, which is agreeing with my original forecast for our area. And you can see that hole still. That's the European, sorry. But you can still see that hole is still there when I'm talking about that little dry slot. I'll wait till about 5:30. And if anyone has any questions, I'll just end the stream. Also, if you want to follow my Instagram here or Facebook, I post on a weekly basis. I try to make like a week forecast for the week every Sunday. So if you're interested in that, you're welcome to check my other accounts out, my other Weather or Not accounts. You can also, if you have any questions later, you're welcome to email me, and I'll try to get back to you as soon as I can. And yeah, thanks for watching. I'll also post these weather maps on my social media, so you can check them out later, and I can see how well I do. This is actually my first weather map as well. So we'll see how I can learn from this and make my maps better in the future.